Hello, welcome. Sorry for the voice, I had a party this weekend and it's still gone. I left it there, so luckily there's a microphone. Hope your energy levels are still okay after the fika. I missed out, so I have to do it on my own energy. But I get to stand and talk, which makes it easier. So thank you for being here. I'm going to tell you something about me, my life. So I hope it's going to be interesting for you. And let's see. Let's start with me then. I'm from the Netherlands. And I studied business mathematics and informatics, which they really intelligently rebranded to business intelligence nowadays. And it sounds a bit more accessible now, but it's exactly the same. And it's actually a data science study. So my hobbies are actually data science as well, but I do also do other stuff, like horse riding, a bit of yoga and reading. So, but then luckily, one of my hobbies is actually data science, which happens to be, I heard, one of the sexiest jobs of the 21st century. Not sure about that, but it is very nice and I do love to do it. I don't know what would make it sexy. I guess the image most of us have from being a data scientist, which is we spend our days building really complex artificial intelligence models and are only working on building the next best 3.0 version of a human who can take over all of our work and is scary at the same time. Well, we actually don't. It's not that exciting. We do use complex artificial intelligence models, but not in the way most people think we do. Another thing they usually think we do is spend our days creating very sexy dashboards. A lot of images, a lot of insights. Nobody ever does anything with because we create so many of them that nobody's interested anymore. I must say we sometimes do this, but this is officially not part of our work. So we do not spend our days creating sexy dashboards. You might get lost now. What do we do then? Well, there's not one data scientist. There's a lot of different ones. And the ones working at the big tech companies like Google or Meta might be very different from someone like me. I'm a consultant. I work for clients, mostly in the Netherlands, for one in Denmark at the moment. And I'm a generalist. So I'm not a specialist. I do very general work, and I really love that because I'm a generalist because I actually have a very big problem in choosing what I really like to do. So that's why I'm not a specialist. There's so much fun in data science that it's too hard for me to make a decision. And since we're all the same, I can't speak for anybody else but myself. So I'm gonna tell you what my day looks like. So today is gonna be my day, which is good. Like I said, I'm a generalist, and I like to be busy, and I like to talk to my peers, and I like to help my colleagues, and I absolutely love chaos because I hate it at the same time. I feel the need to solve it immediately. So if there's chaos, it's actually a bit happy me because there's a lot of value to add because we can create order in the chaos. And that's what I love to do. So how do we do this? Generally speaking, our data science projects, how do they start? Where do we end up? And which steps do we take? Well, data science isn't very new. Most models we use, most intelligent things we use are actually invented in the 50s, 60s. We were waiting for the computers to be strong enough to be able to do more with them. They are, and they are even getting better and better. That's why we see a lot of smart language models nowadays. because we needed that computing power. A lot of the language models, some of them are quite new, but most of it is really old, actually. And so is our way of working, actually. So how about sexy? It's from the 80s. Can still be sexy, but not very new. This is called Crisp DM. It's our way of working when starting a project. And as you can see, it's not really something shocking. It's something that you probably would have expected. We need to understand what the business is doing. We need to understand the data that's available, or maybe data we can collect from somewhere. We need to prepare the data a lot. That's most of our work, actually. And then the fun part starts, the modeling. This is the sexy part of our job, the modeling. Then we go to evaluation. And if we think the model is doing good, then we can start deploying it. For the larger companies, it's not one data scientist doing all of this. You get more and more different specializations. You get machine learning operations engineers. You get data stewards for data quality, but especially for the smaller organizations or the more flat organizations, it can be one person or a group of persons doing this. And it's a circle, it never stops. So that's good for us. So keeps us busy, which is really nice. I'm going to take you through these steps, and I'm going to show you an example. We're going to tell you about an example. But first, this is from the 80s, and there are some parts that are actually a bit broader nowadays. And luckily, more focus is on them now. XAI is explainable AI. It means that if we create a model and it predicts something about maybe you guys, we need to be able to know why it predicts something about you. What's the reason this model thinks you are gonna act like you might be acting? We need to be able to explain that. Why? Well, because you have a right to know, but also to make sure that what we are doing is still ethical. And probably all of you can pop up some really unethical examples immediately from the near future, from the near past. But one of them is actually with the language models. If you ask a language model, or if you ask the really cool models that can create images for you, which is really nice, you type in a text and it generates an image for you. If you type in nurse, you get a female. If you type in doctor, you of course get a male. If you type in CEO, you get a white male of around 50 years old. You could say it's something in our society, but we'd rather not have the models tell us that again and again, that our society is actually, this is what it looks like. And we want it to be more diverse, but diversity we need to create ourselves. So diversity is something we need to be aware of. Bias in our data is something we need to be aware of, because we are the ones working with the data. We are the ones creating the models, and we are the ones using them on everybody, including ourselves. So explainable AI and ethics are finally getting the focus and attention they actually deserve, and they've been deserving for a long time already. And when we deploy models, we're not done. We need to keep an eye on them. Because if we create a good model, if we create a good prediction, and we do something about it, hopefully we turn the model bad really, really fast. So let's say we created a model to predict if you were going to leave a company or not. So if you're going to cancel your subscription or not. So let's say we predict really well, so we know who of you is going to leave. And then we think of something that will make you stay. And that works also really well. But then our model will be really wrong the next time. So if everybody's doing his job really well, the model doesn't have a really long lifetime usually. Depending on the subject, of course. So monitoring is really important. And for me, there are a lot more arrows actually. So The white arrows are the official arrows. But for me, my day in my life feels like the arrows actually go everywhere and everywhere. So officially they're not, but we go back and forth between all of these steps all the time. Which is sometimes a bit difficult, but also makes it very interesting. But these are our official steps. So we start with business understanding and data understanding. If we try to understand the data, we have some questions for the business again about what we don't understand, so we go back to them. And then when we finally understand what the data is about, we're going to look at data preparation steps. And then we're going to look at modeling, but when we are modeling, we might see data that we need to prepare a bit more or differently, so we go back to data prep. And then finally, we get this model or models we think are quite nice, then we try to evaluate them, and we try to find the model that we think is best suited for our subject at the moment, which then leads to a deployment. But the evaluation also leads to talking to the business again, because we're not building these models because we love to build models, partly, but not really. That's not the reason why we're there. We're building this model for people in the business that need them and that want to use them, but they can only use them if we can explain them to them. And sometimes explaining the model to them will lead to the complete disregarding of the model because it's not doing what we want it to do. So there's an arrow back again, and maybe the whole circle starts all over. So to make it a bit more lively, I'm going to talk about one example. And it's about fraud detection, because that's something we can all recognize. Fraud detection is, well, maybe we all did some fraud, like at high school, sometimes. But this is about an insurance company. And we start with talking to the business. What type of fraud do you see? Where do you think there's a problem? What do you expect from it? What do you think you can also use to fix something? Because we might be able to predict something, but if it's not something you can handle in any way, then why bother? It's a waste of time for everybody. So we started to talk to the business of this insurance company. What's your problem? What do you see a lot? What do you think we should look at? What do you think is a big problem in fraud? And they actually came, it's in Dutch, sorry for the non-Dutchies, probably most of you. In the Netherlands in 2017, there was an article from all of the insurance companies together in the Netherlands that actually there are more Ray-Ban sunglasses claimed in a year than produced. So it's possible, of course, because your sunglasses, you have them for more than a year, but probably not all of them are actually really broken or lost. So this is something that they came up with, like, can we take a look at this? Can we predict if this is fraud or not if we are looking at my travel insurance and my sunglass broke again? So we spoke to the business, and now we know about what's going on, we know about the problem. We kind of know the data that we might need. So we spoke to them and we said, well, you know your customers. And you have a gut feeling probably about the reasoning why this fraud is happening or who is committing the fraud. So just enlighten us with all your gut feelings, and we are going to try to find data to see if your gut feeling is correct. Because maybe we can tell you you are wrong, which is fine, but a lot of the times the gut feeling is coming from somewhere, and it means it's data that we could use. So maybe age, maybe gender, maybe the number of times you go on vacation. We're of course restricted with what an insurance company knows about you, about its customers. But we start with an open field, like pretend everything is at hand. What would you like to have? And then we start collecting data. We start looking at the internal systems because usually they are the most valuable for us. But maybe data from outside systems are valuable as well. Like we had this use case where we tried to predict the number of customers coming to IKEA on a day. And the most valuable data was not actually their history of customers coming in. It was a bit because you could see like busy days, Like in Holland, traditionally, everybody goes to stores like IKEA on the second day of Easter, because actually it's not really a holiday and nobody has anything to do, and usually it's bad weather, so why not? But actually the last point was the most predictive value, the weather. If the weather is bad, we love to go to IKEA. If the weather is really good, we spend our time somewhere else. So actually the model we created to help IKEA predict how many people they needed on the floor in the store was mainly weather forecasts. So not a lot of internal data needed there. But usually it's the most valuable data we have, because it tells us a lot about the customers, about their behavior, about the interaction with the company before. You have people who at insurance company are regulars and people you never talk to, and it's a client of yours. So that's where we collect and combine the data. This can take a long time, depending on how well the data is structured, how well it's findable, depending on everything, and also depending on all the people already in the company knowing where data can be found, knowing about data quality. Because sometimes it feels like you hit a gold mine. You're like, oh my God, we have all this data about these customers, and it's shit. It's like not usable at all. Like companies where most of the clients, like insurance companies, where most of the clients are under 18. Well, probably not, because then their parents actually have an insurance, so they don't. So that means we get to do this data prep. We explore the data. We try to find out if everything is there, what it looks like, if we can use it or not, and some more and more. This is what we do a lot. We have a lot of bad data. And it's no problem. Usually we can still use it, depending on how bad it is. But we also prepare the data in some other ways. Like a date is for a predictive model not very usable. It doesn't really say anything, it's just a date, like your birthday. Your birthday is not very relevant if we put it into a model, because there are too many different values. But if we make an age out of it, like just an age, it's usually even better. But sometimes, depending on the use case, we don't want an age, but we want an age category. So everyone below 18, everyone between 18 and 25. That's actually real data prep we are talking about. It's the boring stuff, definitely. But it's also the most important stuff. We have a lot of systems and, AI nowadays that can help us do data prep. But where we still add value is in deciding what data do we need and how will it be of most value, because a system doesn't know that. Not now, at the moment. I'm not going to say it's never going to happen, but at the moment, this is actually where we add the most value. We decide with the business what data do we need and how are we going to prepare it. Sometimes we are also not sure, and we try different ways, of course, but that's what we do. And this is a lot of talking as well. It's a lot of coding, it's also a lot of talking, and it's a lot of creating quite ugly graphs which are good enough for ourselves to just have insights and never show anybody else. And then we let the data speak. So we are creating those sexy dashboards. Not dashboards actually, but we are creating insights looking a bit better than the ones we are creating only for ourselves. We are creating insights we can show to the business to ask them, is this something that you recognize? Does it really surprise you? Because it really surprises you, maybe we should backtrack and see if we did everything okay, if there's something wrong or not. Really simple ones like, do you recognize the amount of customers? Do you recognize their average age? Do you recognize stuff like that? Do you recognize their behavior? Because if you don't, you could be wrong, your gut feeling could be off, but maybe we are wrong, so this is a reason for us to backtrack. So again, a lot of talking. And then we're going to go to the really sexy part of our job, the part where everybody thinks, this is it, this is the cool stuff. I had a lot of people wanting to become a data scientist. sitting next to me and like, okay, now we're gonna model. This is it. This is it. This is gonna be so cool. And then this is it. This is it. I'm sorry. It can be really cool, but this is it. A lot of people are very disappointed the first time, I can tell you. I had a new colleague and he was really into text analytics. So we were working on the text analytics and we did all the talking to the business and we did all the data prep and we were working on that. And then at some point he said like, when are we gonna model? Because this is so boring. I never wanna do this. This is gonna be other people. I'm gonna do the modeling. And I was like, yeah, this is it. He's not a data scientist now. So, yeah. Of course, we create a lot of models, and this is more lines of code, but this is, in general, this is a single model, and this is actually one of the most stable and most used models, which is actually pretty good usually. So, and there are also a lot of tools that can help us build a lot of models at once. So I can also, with this single line of code, slightly changed, I can create 42 different predictive models at once and actually evaluate them with a second line, one line. So modeling is actually the easy part of our job because that's just trying a lot of different types of models, maybe trying some different parameters of the models, but it's not the difficult part of our job. This is the part of the job that is easiest to automate. It's only slow. We need computational power. If we want to know for sure that we got the best model, maybe a deep learning model, maybe some really fancy model, maybe a simple one like this one. This is a machine learning, but a really simple and strong machine learning model. We actually just need computational power. Because for this model, I can change a lot of parameters, and I can just say, okay, try all of them, and we'll see what happens. If I do have days to and can wait, then it's fine. I'll get the best one, I get the best parameters. Probably not a model that is so much better that you can say that you needed all of those days waiting. So we do it a little bit, but not a lot. And now it's time to pick the best model, because we usually generate multiple models to see which model fits our use case best, which model gives us the best results. There are a lot of metrics to do that, and there is no one silver bullet here. There are a lot of different metrics, and they're all very valuable in different situations. So depending on the situation, depending on what you want, it also tells you which metrics should be more important. Let's say we are predicting if a customer will cancel its subscription. Would it be really, really bad if I predicted one of you would cancel their subscription while you were not even thinking about that, so we spent an email or maybe a phone call on you? Would it be really bad? We'll be fine. You won't know because the email is just something nice, so maybe you would even be even happier with the company, so it's fine. So no worries, it just costed a little bit of, it's just a little bit a waste of money. But not a lot of money, it's not that expensive, so it's fine. But what if we're in a hospital and we are using scans and we are trying to predict if what we see, if a mass we see is malignant or not? We don't want to be wrong, we want to be right. And we'd rather be wrong in the fact that we think it's malignant and it's not. And we send you to some extra scans and research because it's not nice, but it's better than the other way around. So that means for these types of models, there are different things, different metrics that are actually important for us. And there are different ways to decide which model, which metric we use to evaluate the models, and in the end, which model will fit the best. And yes, sometimes no model is really good enough, but that doesn't really happen often because before you had the model, it was just random. So if you have two choices, then it's 50-50. Usually isn't 50-50, but even worse. So usually you do get better than that. But how do we pick the best model? Well, GDPR is important. We want to be ethical. So we try to find out if the model is not making unethical choices, like favoring a certain gender or a certain race, or well, we have seen a lot of examples of that. We really try to do that, and it's really difficult because the things we need to evaluate if the model is ethical, mostly we can't use, so we can't really tell. This is going to change with the new GDPR regulations, so hopefully it's going to work. But then again, most companies don't have that information. For a good reason, we don't want them to store that information about us. We don't want them to store our religion or our race or maybe even our gender. I've worked for a telecom company in the Netherlands. It's all about privacy. We were not allowed to use birthdays because why? Why would you use birthdays for analytics purposes? The only reason they stored it is because the bank needs it. Otherwise, they wouldn't even store it. So this telecom company had very, very little data about its customers, and it threw everything away also. After a year, we wouldn't know the usage data of these customers. That's really privacy first. There are not a lot of companies doing that. So we try to be ethical. And we try to think about the customer and what it needs, and like I said, what the model is going to do. The impact of the model on the people it's working on, because it's all of you, it's all of us. It's not mainly the company that's impacting, it's actually impacting us. So we try to keep that in mind, and we try to pick the best model according to that. But then we're back again. Now we have to explain something quite, well, we like to call it black box models. A lot of them, they're difficult to explain. It's difficult to explain why the model is making a certain prediction and for one person and another prediction for the other. We get more and more tools for that, and since a couple of years, but it's still difficult, and there's still a lot of discussion about it, if it's good. And now we have to explain this to somebody that is not very interested in the mathematics behind it. That's not interested at all in all this difficult talk about metrics and being right for how many % of the time. And they don't care. They just want to know, okay, what's going on, and am I allowed to use it or not? So this is not easy, and this is really important, because they are actually responsible in the end of using the model. So they need to be sure that we can use it and that it's okay to use it, and also that it's suitable for the use case still. So we need them to approve or reject, because we are not the ones doing that. In the end, maybe we actually do, but officially we don't. They need to make a decision about that. So again, talking to the business, we do that a lot. Let's say they approve, because sometimes they do. It's time for production. So it's time to form that really big blob of code we created with all these different steps, and not in a very good order, because we thought, oh, we prepped something here and then something changed, so we changed it here, now we changed it here again. Not very feasible and not very easy to maintain if it's in production. And usually we're not the ones that are actually putting it into production, because here are the MLOps engineers, and they're not happy if we give them this blob of code. So now it's our job to clean it up, to make it readable, to make it easy, and to make it repeatable. So might take a while as well. Not all models get it to production, so we tend to not do that until it's really necessary. And then this model should live somewhere. It should be running somewhere. Maybe it's a model that should run every time you get onto a website. Or maybe it should only run when you call on it. Like me and my colleagues, we've created a festival recommender right before COVID. So not very usable. But you could give your Spotify playlist and ask actually the recommender to give you the top 5 festivals you would like in the Netherlands to go to, or in Belgium. So that model has to live somewhere all the time, but it will only do something when you press that button. This is my Spotify playlist. Please give me something now. But there are also a lot of models who we run them every night. because we need to score for the prediction for all of the customers in the base. It's a lot, and at night we can refresh that data. So depending on the needs and depending on what the model is going to do, it's going to live in a different type of setting. But it needs to be robust, and it needs to be easy to maintain. And unlike probably most of you, data scientists are not very familiar with DevOps yet. We're getting there. We're learning. It's a steep learning curve sometimes because we are used to just simply smashing everything together and it just works and it looks good and we're good. We're good to go. We made a nice image out of it. We created a cool model. It's okay now. So we're learning, and it's really cool if you ask me. I'm also starting to create packages in Python now, so it's also unit testing and everything. You guys are probably like, oh, boring. For me, it's all new, so difficult. That's something we need to do as well now. And then the monitoring starts. And it's not so easy to monitor, because the model might not be correct anymore, but the world changes. That's actually the biggest trigger for the model not to be correct anymore. But how do we know if the world changes? We do when it's COVID, but otherwise, did the world change? I don't know. Is it different from last week? Is it different from last month? How do we know? How do we know if the model is still performing? Can we check if the predictions are off? We don't know, because then we had to call customers like, hey, we think you're gonna cancel your subscription. Are you? No? Okay, then we're wrong. We can't do that. So we need different ways of doing that. And of course, luckily we can. So we are checking the data actually. So we check the data we trained on to see for each variable we used, each feature we used, each data point, like gender, are there any changes? And are the changes really relevant? Because of course they change. Like if you get new customers, it's probably not exactly the same ratio of men and women anymore. But up until some point, that's fine. And we can't keep an eye on that every day. So we can automatically do that. So we keep an eye on what we call data drift and model drift, concept drift. So did the world change? Did the world of the model change? And if it did, then we have a few choices to make. Are we going to create a whole new model because did the world change that much that it asks for this whole process again? Are we going to do it all over? Are we going to talk to the business again and see what changed in the world? How are we going to create this new model? Or are the changes more on a bit of the data and there are more men and less women and we can simply retrain our model and we're good? Because that's easier. We can use the same data, we can use the same data preparation, and we just simply repeat the steps of building models and evaluating models. And we can even do that mostly automatic. But we need to make sure that we're not retraining models in a time that we don't want to retrain them. Like right before COVID, we had this model that predicted if people were willing to come to a conference or not, if you needed to invite them or not. And I think a month after the lockdown in the Netherlands started, officially this model was due to be retrained. Well, not a good timing because the world changed and it's not going to be an effective model anymore. It's not now, but it's not going to be better. So probably just need to take this one offline. So that also is a decision we can make. So we repeat. We repeat this a lot. This is my day. This not one day. I wish it would fit in one day. It doesn't fit in one day. All of the talking doesn't fit in one day, of course. So what does my day look like? I made a year out of it because in a day it doesn't fit. First of all, I need vacation. Not a lot, but I do need it. And then I need to learn, because data science, it changes every day. Like, you haven't read some articles for a week and you're like, oh my God, I'm way behind already at some points. Like the NLP, the language processing models, it's so fast nowadays. It's crazy and it's really interesting. So I also love to read about it, but especially being a generalist, it's a lot to keep up with. But so a lot of reading. and a lot of talking. And then the most, data prep, the best. Most of the job, and it's actually not that bad, but it's a lot of work, and it's not something that's easy to automate. It's not something that is easy to copy code from, because there are some parts that are probably the same as the other time, but a lot of them is not, because this is also where we add the most value. Which data are we going to use, and how are we going to prepare it? And then the modeling, not so much time. But then evaluating, that takes a bit more time, of course. That's where we come in the picture again, and our knowledge and our intelligence is important. This is where the computer needs us again. And then the production and monitoring, like cleaning the scripts, monitoring it, even though it's officially not, for most companies, it's not our job, the job of the data scientist, but it's something we know about the model, we know about the data prep, we understand what we did, and we know why. So if there's an alert, we are the ones that can make sure that something is got to be done, and we know what. So this is what my day looks like, actually. So data science, well, it's sexy. I think it's sexy. Maybe it's not all of it, it's really sexy. And we do machine learning, we do deep learning, we use AI, but we're not building these models all day long. It's mostly practical and applicable. We are working for the business, we are working to make sure that somebody needs what we are building. So we need to be practical, and we can't always do the fun stuff. And there's no hiding behind the screen. Sometimes I wish there was, for some days, just for a whole day, me, myself, my screen, happy times. But then I would be bored. So I love talking to the business as well, and we do that a lot. And it's actually very, very valuable. So that's my day as a data scientist. Thank you.